Hello and welcome to the section of the Algebra Tutor. In this section we're going to talk about factoring in a special form that sometimes you come across, and that's called factoring the difference of two squares. Before we write anything, you should read the title again, the difference of two squares. Difference, when you have the difference of two things, it means you subtract them, right? Two squares, or the difference of some squares, means something's going to be squared. So basically, this is going to be a special case when you see two things subtracted that happen to be squares, perfect squares. And we'll talk about it and give us some examples. And I'm going to show you that anytime you see that pattern, there's a certain way you can factor it that's very easy. And once you recognize it, can make your life a lot easier and you can get the answer in very few steps. But before we do that, let me kind of derive and show you how this all comes about. Let's take a little trip down memory lane, and let me ask you, what if you have x plus y, this is kind of a review, times x minus y? How do you multiply these two binomials together? Well, you can do FOIL, right? So you have first terms, which is going to be x squared multiplied together. Outside terms, since you have the negative y times the positive x, can be negative xy. The inside terms is going to be x times y. And the last terms is negative y times y is negative y squared. So that's all correct, but then you realize that negative xy cancels with positive xy, so they subtract to 0. So what you really have here, and what I'll do is I'll write it down again, x plus y, x minus y, is equal to x squared minus y squared. So I'm going to circle this and leave it on the board because, at least for a little while, because this is the difference of two squares, believe it or not. You have the difference of two things that are squared. That's all it means, the difference of two squares. You have a squared on the x, a square on the y, and you subtracted them. Anytime you see the difference of two squares, you can immediately factor it like we have it here. Now, I've kind of done it backwards to show you what it's equal to, but basically, you know, factoring is when we reach into something and pull it out, right? It's when we write something as a multiplication and make it basically where it's equal to what we originally started with. What I've shown you kind of in reverse is that anytime you see this, you can rewrite it as x plus y times x minus y. Anytime you see x squared minus y squared, you say x plus y times x minus y. And this is the factored form of this difference of two squares. So even though I showed you by multiplication, when you go the reverse way, you're basically factoring, and when you see a difference of two squares, you can always write it like this. So let's go and leave it on the board and do a couple of examples, and I'll show you how you could apply this to problems where you have to factor something. What if you have the expression x squared minus 16, and I say factor that? And you look at that and you say, I don't know how to factor that because there's an x here, there's numbers here, there's nothing common, there's no way I can factor this expression. But then you remember, 16 is what we call a perfect square because 4 times 4 is equal to 16. So really you can rewrite this as x squared minus 4 squared. Now, doesn't this look an awful lot like what I have here? X squared minus y squared minus 4 squared. So really what we've said is we've replaced the y with 4, but other than that, this is the same exact thing to what I've written up above. So because it's the difference of two perfect squares, you can write the answer immediately, x plus y, x minus y. It's just that y is 4 now. So you say x plus 4, x minus 4. And that is the final answer. That is the factored form of this. And if you don't believe me, which you should always be skeptical in life, you just check it by multiplying. X times x for the first terms gives you x squared. Outside terms, negative 4 times x is, let me erase that, negative 4x. Inside terms is positive 4x. Last terms, 4 times negative 4 is negative 16. And you can immediately see that the negative 4x goes out with the positive 4x, so what you're left with is x squared minus 16, which is exactly what we started with. So anytime you see something that's a difference of two squares, you might have to rewrite part of it to make it look like a square. But once you have the difference of two squares, you can immediately write the factored form. You don't have to think. You don't have to think about what do I have to multiply it by, like all the stuff we were doing when we were factoring. You literally just write x plus y, x minus y, whatever x and y are in our little representation. So let's erase this and do a few more problems to get some practice. Okay, now what we're going to do now is I'm going to rewrite it on the board. X let's do it like this. Anytime you see x squared minus y squared, basically you just do x plus y, x minus y. This is the rule that we're following. That's really just comes from, you know, all of the stuff we're talking about. Now let's go and work a problem. What if you have y squared minus 49 and you're asked, factor this guy? First you might say, there's no way I can factor, but then you realize 49 is a perfect square. So you can rewrite this y squared minus 7 squared, because 7 times 7 is 49. You have a difference of two squares. You can write the answer immediately. Y plus 7, y minus 7. Y plus 7, y minus 7, just like that. And that's the answer. And if you do FOIL here, you will get back exactly what we started with, just like we did in the previous example. All right, now let's say you have 25t squared minus 36u squared. Now this one looks totally different, but again, you obviously are able to factor it, otherwise I wouldn't present it to you. So you start looking and you realize 25 and 36, they both look like perfect squares. That's a big clue. And obviously you have t squared and u squared, so how would I rewrite this? I could easily write this as 5t all squared minus 6u all squared. Because this square, since it applies to everything inside, is going to go to the 5, making 25. It's going to go to the t, making t squared. This one's going to go to the 6, making 36. It's going to go to the u there. So basically, these two things are exactly equivalent to one another. And once you realize that, you have the difference of two things that are squared. So the way you write the final answer is 5t plus 6u multiplied by 5t minus 6u. You literally just say this plus this multiplied by this minus this. And that is the final answer. All right, now what if you have 8x squared minus 32y squared? Again, it doesn't look like I have any kind of perfect squares here, and in fact 8 and 32 are not really perfect squares, so you're kind of stuck. But then, you know, my advice is always just try to do what you can. We know we can pull out an 8 from both of these because 8 times 4 is 32, so let's just do that. Pull out an 8, so what we'll have here is x squared left over, and here, since 8 times 4 is 32, we'll have 4y squared. Now things are starting to look up because I have a square here, and 4 looks like it's a perfect square. So before we get ahead of ourselves, let's write it like this. So we'll open a bracket just to make it clear. We'll have x squared minus 2y squared. Now you can see what I've done here. X squared stays the same, and I change this to 2y all squared because I know when I distribute that exponent in, I'm going to get back with what I started. Basically, I'm just taking the problem, and I've got a hammer in my hand, an algebra hammer, and I'm beating it into the shape that I need it to be in. I need the difference of two squares. I know that 4y squared can be written as 2y all squared. And I want it written that way so that I can easily write the answer. So what I'm going to have is 8, and then here it'll be x plus 2y, x minus 2y. Because it's the difference of two things that are squared. Once you have that written down, once you've got that figured out, then the rest of it is basically just mechanical. What if you have, just to get some more practice, 3r squared minus 12s squared? Doesn't look like I have anything, you know, like a perfect square, but I know I can pull out a 3, so let me see what happens. 3, I'm going to be left with r squared here, minus, over here I'm going to be left with 4s squared, and exactly the same thing pops out. I have a 4 left over, which I know I can use to beat this thing into shape. So what I'm going to have is 3, and then over here r squared minus the 4s squared, I'm going to write it as 2s squared, because I know the exponent will apply to both items. So now I have the difference, which is the subtraction of two things that are squared. And so now it'll just be 3 times r plus 2s, r minus 2s. And that is the final answer. Now let's say I have 4x to the 4th power minus x squared y squared. And I'm going to try to find a way to factor this guy. It doesn't look like it's possible at first. Well, I see that I have an x common to both places, But then I realized that I can rewrite both of these terms. The first one can be rewritten as 2x squared all squared. You want to write something as a giant square. This applies into here. This applies 2 times 2 gives me 4. So that makes sense. And then I have a minus, and this can be written as x times y all squared, because the exponent is going to apply to everything on the inside. So I want to try to write it as the difference of two squares, and now that I've done that, the answer is very simple. The factorization is 2x squared plus xy, 2x squared minus xy. 2x squared plus 2y, 2x squared minus xy, and that is the difference of two squares factorization there. Okay? And what if you have a to the fourth minus b to the eighth? Now we're getting to higher and higher exponents, so we can expect a little more work. Let's see if we can write this as a difference of two squares. I can write this as a squared squared, because 2 times 2 is 4, minus, I can write this one as, what do you think, b to the fourth squared, because 2 times 4 is 8. So I have the difference of two squares right in front of me, so I'm like, all right, I'll just write it down. A squared minus b to the fourth, I'm sorry, plus b to the fourth, a squared minus b to the fourth. And you could almost stop there, really. I mean, that is the difference of two squares factorization, but then I realize that I can go a little bit further, because here I have another difference of something that I can write in terms of two squares. So let me show you what I mean. This is going to stay the same, a squared plus b to the fourth. This guy can be rewritten as a squared minus b squared squared. Let me change this to a bracket to make it clear what I'm doing here. So you see, this stays the same. The b to the fourth is written as b squared squared. So here I have another difference of two squares in the same problem. And so what I can do is rewrite this term. So first, this is going to stick along for the ride, a squared plus b to the fourth. This is going to be, since I have the difference of two squares, it's going to be a plus b squared, a minus b squared. You take this guy that's in the middle and this guy that's squared, and there's the answer. A squared plus b to the fourth times a plus b squared times a minus b squared. That's the final answer. So literally all you're doing is you're trying to write as many terms as you can. If you think you might have a difference of two squares, like you kind of suspect it since you have something that looks like it might be able to be rewritten, then do your best to write it in terms of the difference of two squares, and then you can write the factorization right away. All right, now let's say we have 3 times a to the 10th power minus 3 times a squared b to the 4th power, and we want to factor this as much as we can using the difference of two squares. Before we do anything else, I see that I have a 3 common, so I can definitely pull the 3 out. And I also see that I have an a squared here, and I could pull 2 of the a's out from there. So let me pull out 3a squared and just see where it leads me. Inside, I'm going to have a to the 8th left over, because if you multiply these together, you add the exponents. And over here, I'm going to have, since I pulled 3a squared, I'm just going to have b to the 4th, right? Now this suddenly looks pretty good, because I'm pretty sure I can write these as a difference of two squares. In fact, I think we did that a couple of problems ago. So let's rewrite it. 3a squared, and on the inside here, let's write a to the 8th as a to the 4th power squared, because 2 times 4 is 8. And then we'll have b squared squared. So we're just writing them as square terms. And once we have this, we can just say 3a squared, and then it'll be a 4th plus b squared, a to the 4th minus b squared. So we just do the difference of two squares factorization, and we think we're done, but then we look at this and we say, oh, we have another difference. And I'm pretty sure I can write these as square terms as well. So let me try to do the whole process again. 3a squared, a to the 4th plus b squared. So you can't do anything with this because it's summed together. You have to have the difference of two squares for this to work. And then you have, I can write this, let me put a bracket here to make it a little clear, a squared squared minus b squared. So I have, again, the difference of two things that are squared. So for the final answer, you have 3a squared, a to the 4th plus b squared. And then this guy is going to be a squared plus b, a squared minus b. It's whatever is the base item that's being squared. You do that plus the other one, that minus the other one. So finally I have 3a squared, a to the fourth plus b squared, a squared plus b, a squared minus b. This is the final answer. All right, that's the final answer. Now moving along these lines, we'll do another one right below it. What if we have 16x minus y squared minus 9? Now, this looks kind of hopeless, but then I realize 9 is a perfect square, 16 is a perfect square, this is already squared, so I'm pretty sure I can rewrite this and beat it into a shape, into a form that I like. So what I'm going to do is try to rewrite this in terms of squares as much as I can. 16 is 4 squared, and then I still have x minus y squared. 9 is 3 squared. Now this is almost like the difference of two squares, but this looks a little bit different than what I have had in the previous problem. So I kind of want to combine it into one item that's squared. So the way I'm going to do this is I'm going to say 4 times x minus y, and I'm going to square the whole thing, minus 3 squared. This is totally legal because this exponent is going to operate on the 4, like that, and then it's going to operate on the parentheses just like this. I do it that way because with difference of two squares, you want one item squared minus one more item that's squared. And I have to beat it into that form. But once I have it here, I know the answer because it's going to be 4x minus y plus 3, which is being squared over here, times 4x minus y minus 3. Basically, it's this plus this times this minus this guy right there. Now, occasionally I give you these techniques and I'm always hoping that you'll apply it to real situations. So here, let's learn how to solve a different kind of equation, like this. X squared minus 25 is 0. We want to solve this equation for x, and just like any time we're solving equations, we want to isolate x. But we don't have a great way to do it because it's squared like this. So how do we handle that? Well, one way to handle it is to factor it. And if you factor it, set it equal to 0, like we did in some previous problems, we'll be able to solve it. Now, before this lesson, you really didn't know how to factor this, but now that you know that 25 is a perfect square, you can rewrite this as x squared minus 5 squared is equal to 0. And now you see you have the difference of two squares. So that means that this will be x plus 5 times x minus 5, and that's equal to 0. Now prior to this lesson, you wouldn't know how to factor this, so you couldn't get down to this part. But once you're here, you should remember from previous lessons that I can set this equal to 0, and I can also set this equal to 0. So what I'll have is x plus 5 equal to 0, and I'll have x minus 5 equal to 0. Either one of these going to 0 will drive the whole thing to 0, and it'll be valid. So solving for x here, subtract 5 from both sides, you'll get negative 5. Here you add 5 to both sides, and you'll get a positive 5. So there's two values of x that will satisfy my original equation. Not one, but two. And let's see, if you take 5 and put it in here, 5 squared is 25. 25 minus 25 is 0, so that works. If you take negative 5 and put it in here, negative 5 times negative 5 is also positive 25. Minus 25 gives you 0. So negative or positive, no matter what, if you put a 5 in there, negative or positive, you're going to satisfy that equation.